Hi guys, and welcome back to my Unreal Engine 5 multiplayer FPS course. Now in the last part we had come to a stage where if we would go on the pickup, that is if we overlap a pickup, we would see the pickup widget. But right now it actually does not do anything. So you could press F, but nothing's really going to happen. So we are going to start setting up our inventory. So I initially thought we would do this in C++, but keeping the complexity in mind, I thought I would just do it in Blueprint, and the function isn't going to be too much, affecting our performance or anything. So we'll be doing it right here. So create a new Blueprint class, and this will be of type player state. So player state. We will create a CPP player state if we require, but for now we'll call this one BP player state. Open it up, and we also need a struct. So under actual content structs, go ahead and create a new struct. So blueprints structure, and we'll be calling this one inventory item. So this will be containing all the information that's required for us to store something in our inventory. So let's begin. So let's assume we have certain amount of space in the inventory. So the item itself will be occupying a little bit of it. So first of all, we'll have a name. So that will be of type string, and we will add in another variable, and this one is going to be quantity. And just to show it in our inventory, we will have an image as well. So this one is going to be a texture 2D. So texture 2D it is. Texture 2D object reference. So this is what we will be having. So over here in our pickup, we can open it up actually, or rather it should be in blueprints, pickups, pp underscore pickup, and we can go ahead and create our variable. So the variable is going to be our inventory info, and this one is going to be of type inventory item. And since we want quantity to be replicated, we will make this entire variable marked as replicated. Alright, and over here where we had left quantity blank, so what we can do is we can get quantity from this struct and we can plug it in right there. Now inside our player state, head into your event, or actually you don't need to, create a new variable, and this one is going to be an array of inventory item. So we are going to be calling this one inventory, and this one is going to be an array of inventory items. So inventory item, and it's going to be an array. Alright, and this one is going to be replicated as well. We might need to make it rep notify if we need to. We'll look into that a bit later. So we need a couple of functions now. The first one is going to be add item to inventory. So if we already have a particular item, we want to just add the quantity, but if we do not, then we want to add the item to the inventory. So the way we'll be doing that is we'll be iterating through our inventory. So we are going to do a for loop. So for each loop, and we are going to split the struct bin, and if the name is equal to the item we are adding, so let's actually add that. So item, inventory item. So this is the item that we are going to be adding. So if the name is exactly equal to the item name, so split this bin again. If it is in fact equal, so what we are going to be doing is we are simply going to be adding the quantities. Now assuming we have enough backpack space, so the way we'll be checking this is, okay, right now we do not have a backpack space variable, so let's actually add in a variable for backpack space, or basically our inventory space if I have to be more precise. and this one is going to be of type float. So this is going to be our total inventory space, and it's going to be a float. Now we can also have another variable for inventory space used. Right now we can put all of this into one function actually. So we can collapse this to a function. We'll see what is to be done with this. So this function is going to be item exists, and we can make this one pure because we can call it every time. So this is the item name that we have, and once we iterate through it, we see if it exists. We can create a new local variable, and it's going to be called exists, and this one is going to be a boolean. The default value is going to be false, and we can set it to true if it actually exists. And once the loop is completed, we can go ahead and return. Now over here in our add item to inventory function, so in our return node we need to have in our boolean here. So we'll call this one exists, or we use the name, so let's just call it return value, and we can just pass in exists from there. So head back into your add item to inventory. So now we can use our item exists function. So this makes our job a lot easier. So if the item already exists, now there are multiple cases that are possible here. So if the item exists, there is a chance that let's say we have 30 bullets on the ground. So let's say we have 556 ammo lying on the ground, and we have 30 of them. Now there is a chance that all the 30 is going to fit in the inventory, but there's also a chance that only part of it is going to fit. So we need to account for that. So if this item does not exist, we again have to do the same checks. But if the item exists, we are just going to add the quantity that is that we can add without using up all the space. So we have no indicator to how much space this is occupying, so we can go ahead and add in a new integer over here, or rather a float, and call this one space occupied. So this is going to be per one quantity, so this is going to be of type float, and we can head back. So this is the space occupied. So now we can do a couple of if checks. So we can grab in the space used, and we can add it with the quantity multiplied by the space occupied. So the space used plus the quantity multiplied by the space occupied. So this is going to be the space which this item that we are adding will use up. So the result which we get over here, and will add up to our use space. Now the value which we get here is the amount of space which will be used up once we actually add in all the items. So now the first case and the best case scenario for us, which is the easiest in terms of logic, is going to be if all of the items fit in our inventory. So if this is less than, so float less than float, so if this is less than our inventory space, that would be the best case scenario. So if the item exists and it occupies less space than our inventory, we can do an if check here. If it occupies less space than our available space, we can go ahead and add it without any hesitation. So we can get this item. So we can also return the index actually. So we'll promote this to a variable, or rather local variable. So promote to local variable, and we'll call this one index, and we can return that as well. We'll call this at. So this is going to be the index at which our item actually exists. So we got the index as well. Now actually we shouldn't make this pure because the function will be called 2 times unnecessarily. so we won't make this pure. So the item exists, and if it does exist, we do have an index, so we can just directly add in the quantity, so we can get a reference to it. Now the reason we are getting a reference is because we can edit the values right there. So that's the reason we are getting a reference. Now what we can do is we can go ahead and we can set the members over here, or we could do set array element. That works as well. So set array element, and the index is going to be this one. And over here we can split the struct pin, and everything else is going to remain the same. Actually, we still need the reference to it, so get ref. The reason I'm getting reference is just to avoid another copy being created, because we do know that this item exists, so it is safe. So over here we can break this one. So the name is going to remain the same, the image is going to remain the same, space occupied is going to remain the same, and the quantity is going to be added. So the quantity over here is going to be the quantity which we have plus this quantity. So this is going to be our resultant quantity. Okay, so now let's get to the case where we actually cannot fit in everything in our inventory. So if we cannot fit in everything, we want to fit in as much as we can. So the way we'll be doing it is we'll be doing a for loop. So add in a for loop. So the first index is going to be 0, and the last index is simply going to be the quantity minus 1. So in fact we don't need to do this, we can directly plug this in and we can put our start index as 1. So now what we can check is, so we can copy this over, and so this is going to be the space occupied into, instead of the quantity, what we can do is we can multiply it by our index. So if this value whatever we get is less than our inventory space, then it's absolutely fine. If it is not, then we cannot add those many items. That's what it really means. So we can do an if check. So if it's possible, then we can go ahead and head into the next index. So then we can check if we can add one more item. So then we'll be going back to the next iteration of the loop. And if this is false, what will happen is, what we can do is we can get the index minus 1. So this is the quantity that we will be adding. So what we can do is we can collapse this to a function once again. So collapse to function, and we can call this one add, or rather we can call this. So let's see what we are actually doing here. So this one is space occupied, so space occupied, and the first one is last index, that is probably appropriate. And we can promote this to a local variable, and we can call this one quantity to be added, and I guess that's what we can call the function itself. So this function is going to be called quantity to be added. So I doubt we can do that, so quantity to add. So that works. Now if it's false, so we are going to get this value, and we have to break. So what we can do is we can just go ahead and get a for loop with break instead. For loop with break, and can plug in the execution pins. First index is going to be 1. Put this in the loop body, and we can go ahead and head into our break. and we can return our value. So add in the return node, and this one is going to be the index, and quantity to be added is going to go right here. So we'll call this one return value. So head back into our add item to inventory, and we can get our quantity to add. So we can make this one pure, or rather let it be as is. Now we got the quantity to add, but we haven't actually set our inventory. So we can just copy over this code, and for our index we will again grab this, and our array is going to be this one again, our inventory. So we can duplicate that, and the index is going to be the same, and it's going to be quantity plus this value, and our target array is going to be inventory, of course. Make sure you have set that. So once you set all of this, you should be good to go. And in case we have this value as 0, so nothing is going to be added to our inventory. So that's about it. Now if this is false, then we do not have the item. So we can copy over this logic. Now we are checking if the item fits entirely. If it does, then we can just go ahead and add an element to the array, our inventory array. So add. So if it does fit, we can go ahead and add, and it's going to be our item itself. So let's actually get our item. So get item. So if you guys didn't get what I did here, it's basically this struct whatever we got. You don't need to just drag in the wire or anything. You can directly use item from anywhere. We could have done the same over here as well. Don't know why I did that. So we can add it, and if it is false, so we'll get how much quantity we can add. So last index is going to be quantity, and space occupied is going to go into space occupied. And now what we can do is, once we get the quantity to add, we can go ahead and do the same thing. So copy these two over. Oops, I cut them by mistake. So the name and stuff is going to remain the same, but this time the quantity is only going to be the quantity which we can add. So this is going to be our inventory logic. Alright, so this function should in theory work now. So we can go ahead and create a return node for this as well. So return node, but there's one more thing which I do want to do. We want to force net update. There is a reason. So if you head into your player state, you see that the net update frequency is just 1. So this can lead to things being very laggy. So I always like to call a force net update, especially when it's something important such as the inventory. So that's about it, and let these two variables be replicated as well. Inventory space used as well as inventory. And we also need to update our inventory space used, just in case you forgot that. So drag this to the force net update, drag this over here as well, drag this over here as well as over here. Now we'll also add in a boolean here, just to make sure that we have added everything. So success, or rather we'll call it added. So if this quantity is 0, it means that we haven't added. So let's actually get separate return nodes, so that would be better. So quantity is not equal to 0, then it means that we have added it, and we do want to call in our force net update. Alright, and now what I do want to do is get another return node, and in this case, yes, we did add it, but in this case I want to do the same check once again. So if this is not equal to 0, it means we have added the item, otherwise we haven't. Over here we clearly have added the item. Okay, cool. So we're done with that, and make sure you call force net update in each one. Copy that over, paste that in once again. So that should be good. Now we also want to update our inventory space used, because our inventory space used will not be updated on its own. So for the inventory space used, what I'm going to be doing is we are going to be setting the inventory space used before the force net update, of course. So inventory space used, this is going to be equal to, we are going to loop through our inventory basically. So we are going to do a for each loop. We'll collapse this to a function. So delete that. So split the struct bin. So this is going to be quantity multiplied by our, rather we'll do a float multiplication. So quantity multiplied by the space occupied. So we'll add this quantity each time to another local variable. So we'll collapse this to a function, and this is, we are going to just promote this to a variable, and we will call this one rather local variable. So local variable, so promote to local variable, and we will call this one space. So it's going to be space plus this value, whatever we get. And once we have completed our loop, so we can go ahead and return this value. So we can return the value, and we'll call this one return value, and we'll call this function get space used, and we can make this one pure. Now head back into add item to inventory. We got space used. We can just do this before the net update. So copy this, rather before the net update. Cleaning things up a bit. Over here as well. So one thing to note, guys, this logic isn't going to work yet because we haven't actually called the function. So until we are going to call the function, none of this logic is going to work. But once we do call it, we can debug if we do have any errors, and if we don't, then that's great. We can continue with our weapon systems. So alright guys, the video is getting lengthy, so that's it for this video. Thanks for watching. I hope you guys learned something new, and if you guys did enjoy the video, make sure you guys do leave a thumbs up, and I'll see you guys next time. Goodbye.